able to record without a problem. So we have it up and running for lecture 15, linear equations. So we're going to record this, go over it, and then when we come back from lunch, hopefully we'll have time to do some work. Oh no, we're not coming back from lunch. Yeah. Sorry, you guys don't come back from lunch. So we may just get through this. Last hour we got through with like 2 minutes to spare. So it's kind of up to you. Tell me everything you know about a linear function.
Linear.
That's good. I have that on recording. Something maybe not quite as obvious.
There's only one function.
What do you mean by only one?
Like, there could be like a positive or negative. Yeah.
Positive or negative what?
Exponent.
Okay, so when it comes to exponents, there's only one. So it's first degree. We call that a first degree. Because all we have is an x, like x equals y or y equals x. Let's come back to you. One what?
One real number.
Give me a little more. One real number. Because, okay, so what's the domain of linear functions?
X.
No, that's the exponent of the value. What's the domain? What numbers can we put in for x?
All real numbers.
All real. So then what's our range of linear functions? Also all real. Now there are a couple exceptions of those, right? So you said there's positive and negative what? Starts with an S, rhymes with hope.
Sum.
Starts with an S, rhymes with hope.
Slope.
Slope. So we have positive slope goes up, right? Negative slope goes down. And for those, our domain is all reals and our range is all reals. But well, how else can a linear function go? Horizontal, which in that case it's not really linear anymore. We call it a constant function. And its slope equals 0. And that has a range of just whatever the value is. Okay, besides horizontal, how else could it go? Vertical. Testing your minds a little bit here on this one. There is no domain, or the domain is only one value. It's not all reals, it's just one value. But what's the slope?
0?
No. Horizontal has a slope of 0. Vertical has a slope that's
10
undefined. Very good. I knew if I gave them time. Very good. Undefined. Okay, very good. Now we've been using this word slope. What is slope?
The rate of change.
The rate of change. I much prefer that term for it. Rate of change. Okay. You're going 60 miles per hour. Your rate of change is 60 miles per every hour. That's your slope. That's your velocity, your speed, whatever. Okay, what else is slope? Can you give me something else more tangible? More mathy. Rate of change is more realistic. Let's do something more mathy.
X equals -11.
No. I'll give you a hint. I just went to go see a movie this weekend. Just came out on Friday called The Running. So slope is what?
Running.
No. That's the word running.
Oh, rise over run.
Very good. Rise over run. Okay, so we have our change in y over our change in x, rise over run, rate of change, all those things are our slope. Okay, anything else you know about linear functions?
It never changes.
Say again?
It never changes.
What do you mean it never changes?
Like, it's always a consistent line.
Okay, so the slope doesn't alter. It's going to be a line. Therefore, if the slope is down here is 2, the slope up here is 2, the slope everywhere is 2. Okay, if it's -1, it's -1 everywhere. Okay, very good. The slope does not change. Okay, very good. Now we're going to look at today. I put Roman numeral 1, but honestly, it's our only point today, and that is solving. Solve linear functions. Now, when we solve linear functions, we're going to do what everybody wants to do when we get to quadratics. So tomorrow we're going to get to quadratics, or actually for you. Yeah, it's for you tomorrow. We're going to get to quadratics. Quadratics you solve differently. With linear functions, our goal is to get x by itself. X equals whatever the value on the right is. Okay? So that's my goal. Now when it comes to quadratics, we solve them a little differently. So I'm actually going to do one problem today. We're going to do it two different ways. One of them, like linear, like we're going to solve with linear, and then one we're going to show you how we're going to solve with quadratics. Okay? So very simple problem. This should not be too difficult. I'm going to give you 2x minus 6 equals 0. And most of us can look at that and tell me what's the answer.
X equals 3, -3.
Positive 3. X equals 3. Because 2 times 3 is 6. 6 minus 6 is going to be 0. Now, if we were to walk through all of our steps from, 7th grade when we learned two-step equations? The first thing we do is we add 6, right? So I get 2x equals 6. And then I'm going to divide by 2, kind of doing my PEMDAS backwards, and x equals 3. Okay, so we know that's the correct answer, right? So let's do it a little differently. Let's solve it the way we're going to use quadratics, but it also teaches a very, very important concept. Okay, let's take 2x minus 6 equals 0, and let's factor that out. What does 2x and 6 both have in common? 2. Outstanding. So I'm going to factor out a 2. I'm left with x minus 3 equals 0. Now, back when you were in Algebra 1, more than likely they taught you this. If I didn't give you the name for it, I'm going to give you the name. It's called the zero product theorem. Or when I write it on the board, it'll be ZPT. What does the zero product theorem state? Do you remember?
That product is always 0.
Product is always 0, not necessarily. But if I give you two numbers like a times b, and a and b are real numbers, okay, any real number, any integer, any fraction, and that is going to equal 0, what does that mean about a and b? If a times b equals 0, what do I know about a and b? One of them has to be 0. I can't have two non-zero numbers somehow multiplying to equal 0. So either a equals 0 or b equals 0. So in my example here, I have two things multiplied. I have 2 times x minus 3. So either 2 equals 0 or x minus 3 equals 0. Now, can 2 equal 0? No, that makes no sense. So we discard out that one, and we say, okay, x has to be equal to 3, which is the same answer I got over there. Okay? So we can use that. Now, when we come to quadratics, that's one way we're going to have to solve it. Either that or the quadratic formula. Okay, we use that zero product theorem. Factor them. Two numbers that multiply together to equal 0. One of them has to be 0. Zero product theorem. Okay. So the other thing we're going to talk about this hour is we're going to do this thing called clearing fractions. Okay? I don't know how many of you have done this before. We had a teacher here at middle school a few years ago that was very good at teaching this. The kids came in, they knew how to clear fractions. So if you're taking notes, clear fractions is a very, very important concept. So let's do one that's a little bit simpler to begin with, and then we'll get to the one in my notes that's a little more complicated. So let's say I have 1/2 x plus 3/5 equals something like 2. 1/2 x plus 3/5 equals 2. My answer is probably going to be some ugly fraction. Okay? But I don't want to deal, because if I subtract 3/5, now I have 2 minus 3/5, I have a fraction. Okay? So before we do anything, let's go ahead and get rid of all the denominators. Let's get rid of all the fractions. So what we're going to do is, first of all, we're going to take the least common denominator. So I have the denominator of 2, 5, and technically I have a 1 there, right? So what's the least common denominator of 2, 5, and 1? That's the least common factor, which is. So I look at the multiples, and I'm like, okay, 2, 4, 6, 8, 10, 12, 14. And I take the other factor 5, 10, 15, 20. And I find the lowest one that they have in common. So in this case, they both have a 10 in common. Okay? So that's my least common denominator. Okay? So I find my least common denominator. Number 2, I multiply every term. Okay? So I come up here and I say, okay, so I've got a term here. I've got a term here. And then I've got a term here. So I'm going to take each one of those and I'm going to multiply my least common denominator of 10. So times 10, times 10, times 10. Okay. Now, what is 10 times 1/2? Half of 10. 5. And my denominator is no wrong. I take 10 times 3/5. What's 10 times 3/5? 10 times 3 is, divided by 5 is 6. So plus 6. And lo and behold, my denominator is gone. Equals, and this side's easy, 2 times 10 gives me 20, and my denominator is not gone. I've multiplied everything by the exact same value. I've gotten rid of my denominator. Now I can just solve like we have been. Subtract 6. 5x equals 14. So x equals 14. I have an free fraction. But the key here is clearing fractions is to simply take the least common denominator and multiply every term by that. Okay? Si, you got that? The other way to look at it too is if I look at each individual one, like 10 and 2, I'm taking the number I'm multiplying in the denominator. 2 goes into 2 once, 2 goes into 10 5 times. 5 goes into 5 once, 5 goes into 10 2 times. And I have 5x and 6. Kind of make sense?
Yeah.
Okay. We're going to go through one a little more difficult and a couple little parts of it, but I'm going to go through now the 5 examples from Delta Math. Okay. On Delta Math, we have, I think it's 7 different sections in this particular homework. Maybe it's 6, and each one has a different type of problem. We're going to go through an example from 5 of them. Okay. So the first one's fairly simple. It's kind of a refresher. 7x plus 1 equals 5x plus 4. No, plus 9. Okay, now, I'm going to do something that only professionals can do. I'm going to show it to you. If you'd like to practice it sometime, you're welcome to try it and practice it, but realize I'm a professional. I'm going to attempt in math class. Messiah, you ready? Yeah. I'm going to do 2 things at once. I know. It's like way out there. Okay? So hopefully you catch a little bit of sarcasm. So what I'm going to do is move all the letters to one side and numbers to the other. So I'm going to go and subtract 5x. But at the exact same time, I'm going to move the 1 away from the x's. Messiah, I think you already did that, didn't you? Yeah, your first step you already did. So I'm going to end up with 2x equals 8. So x is going to be equal to 4. Okay? 1 to 5. You good with that? You got 5s on that order? Beautiful. Second example. Excuse me. 5 times the quantity x minus 3 equals 40. What are 2 things you could do first on this one? What's one thing I could do first? I can do what?
5 times x, 5 times negative 3.
Just sugar out the 5. Absolutely, we can do that. What's the other thing I could do? Might save me a little time. It'd actually be fewer computations. So you said it's 5 times something, right? So let's have to times 5. Divide both sides by 5. So then I have x minus 3 equals 8, and x equals 11. So you can do that as well. Distributing is fine, but sometimes if you see the possibility of dividing, it's a little.
So you can't do that if, like, you can't divide, like, let's say, like, 38, like, you can't do that.
Then you would end up with a fraction, and I probably wouldn't do that. But as long as I see that it's visible, I would divide it. Yep. Another thing, too, is if I have 5 times x minus 3 plus 2 equals 40, well, then you would have to subtract your 2, and then you would probably want to distribute that. Yep. All right, another example, I would like for you to try this one on your own. If you want to do it on your desk, there's some whiteboard markers you can use. Just make sure we erase them. Let's try this example. This example is another one on Delta Math. It's going to take it up a notch. Quite a few more steps. So please be careful, but just try this one. 4 times 2x minus 5 plus 3x minus 4 equals negative 11. Now your final answer will have, did that work? Okay, so that one work? I got 2 more over here. And you can just write directly on the desk. That works too. Your answer will be a fraction on this one. A really ugly fraction.
Can I get a different marker?
Yeah, just throw it away. Are you okay being on video, or would you like me to pause it? Okay. All right.
Never miss.
Show the entire.
No, I never miss.
So show the entire problem.
Show the whole, show everything you do on your paper. Hope it works. Does it work? Beautifully done. Could have done it better myself. You got it? 5 on this one? You good on this one? Beautiful. Alright. Let's go to 2 more examples. We're right done 2. We've done 1, 2, 3, done 3. Okay, last 2 examples, but these are going to be dealing with clearing fractions. Okay? So let's try these with clearing fractions. First one's going to be very similar to what we've already done, where I'm going to give you 2/3 times 6x plus 15 equals 6. And actually that should be minus 15. So it sounds good with my notes. So 2/3 times 6x minus 15 equals 6. Now, what's the least common denominator?
1.
3. 3 is the denominator. So 3. So we're going to multiply everything by 3. Okay? So I'm going to multiply here. And this happens to be one term, right? We have a binomial inside, but it's being multiplied. So that's one term. So I'm going to multiply that by 3. And this is one term over here, so I'm going to multiply this by 3. Okay. So what happens on this side?
Multiply by 3.
And what occurs? When I
They
do
go
that?
up.
Say it again?
They go up by 3.
Actually, what can I do with the 3 on the top and 3 on the bottom?
They cancel out.
I cancel it out. So I'm left with 2 times 6x minus 15 equals 18. 3. And now you can either distribute like the last one, or I can go ahead and divide. I'm going to go ahead and divide 6x minus 15 is going to be equal to 9. So that's going to be equal to add 15 to that. Got it. You want it? This is actually a legitimate interruption. It's actually not really a packet. It's a handout. Any problems, do Friday. Thank you. True proofs. Good enough. I'm going to do one of them in class, so look for the notes myself. Okay, you got 4 on that one? Okay, here we go. Last one, and then I'm done for lecture number 15. This is a short one, but this is going to be a little more of a challenge. So we have 3x plus 4. I can't remember. Okay, I'm going to make it up. 3x plus 4 over 2 minus 3x plus 6 over 5 equals x plus 4. Okay? So let's get rid of those fractions. What am I going to multiply by to get rid of those fractions? 10. The least common denominator of 2 and 5. So remember then, this is a term, this is a term, this is a term, and this is a term. So I have 4 different terms here. Okay? And I'm going to take each one of them and multiply them by 10. Sorry, you good so far? So what am I going to multiply? What's going to happen here? I have 10 on top, 2 on bottom.
5.
Okay, so 2 goes into 2 once, 2 goes into 10 5 times, and I have 5 times the quantity 3x plus 4. Minus, same thing. 5 goes into 5 once, 5 goes into 10 twice. 2 times 3x plus 6. Okay, somebody else, what's on the other side?
10x plus 40.
10x plus 40. Right? And then now it's just a multiply, combine like terms, all this type of thing. So read to me what we have here.
15x plus 20 minus 6x plus 30. Wait. Negative 6x plus 30. Right.
Minus 12. Because negative 2 times positive 6.
Oh, 1, 2. Yeah.
So negative and a positive is a negative. 2 times 6 is 12.
Yeah.
Negative 12. And then we saw the 10x plus 40. And then you can combine on the left-hand side. 15x negative 6x gives me 9x. 20 minus 12 gives me, very good, 8. Equals 10x plus 40. So I'm going to go this direction, subtract 40. Subtract 9x.
It doesn't matter which direction, like,
It doesn't. What I always do is look at the x coefficients, and the smaller one is the one I move. So since 10x is bigger, I move the 9 because then I'll get a positive. Doesn't matter though, you just have to make sure you keep the negative. So here we have negative 32, and 10x minus 9x is 1x, and there's 1x. So no, it doesn't matter. Some teachers say x is to the left, numbers to the right. Some are like me,